for our ME361 Thermal Fluids Lab. Today's experiment will be axial heat conduction. We'll be exploring thermal conduction through solid materials. The setup we have initially is our heater control panel. Here you have your temperature readout. You will change it for each thermistor along the array by changing this button. Here we have your power input. That will be the heating element supplied. Over here you have your temperature control for the water. That will be cooling at the end of the setup. Further down you have your thermistor arrays here. Each one is numbered, and that corresponds back to the thermistor selector on the heater control panel. You will have a slot located here. Each of 3 samples are provided for testing. You will have a 1-inch brass sample, a 1-inch stainless steel sample, and a 1/2-inch brass sample.
Alright, the next step is to make sure that the unit has reached steady state at 325 degrees Fahrenheit. Once that's been accomplished, you come over here and you set the mass flow rate to be at 2 gallons per hour. Once you have done that, you come over here and you choose the 1-inch brass setting will be the first sample that you test. The most important thing that you need to make sure of is that each end of the brass is properly cleaned, and once it is properly cleaned, there is a thermal compound paste which you apply a thin layer to each end of the 1-inch brass. Once that has been done, it's prepared to be placed in the thermistor array. It's key to not touch either side of the thermistor array because it is hot. Once this is done, you place the 1-inch brass sample and you lock it in. Once it has been locked in, you place thermistor 4, 5, and 6 in the holes. Once this is done, you are ready to start taking calculations. And you will come over here and you will check thermistor selector 1, which will give you the temperature at 0.1, and after that you will switch it to 0.2. You make sure that you allow 5 seconds for the unit to reach steady state, and at each of these intervals you will check the temperature, which the temperature is in degrees Celsius, and you will also record the power, which is in watts.
After you finish experiment 1, you're going to cut the main control panel off, and you'll come over here and remove the first 6 arrays, thermistor arrays. Then you'll take the 1-inch brass sample out. Sure, and you're not going to touch the inside sample. Then you'll take the 1-inch stainless steel sample, and you're ensure that it's clean on both sides. Then you'll take a little bit of thermal paste and apply a thin layer to each end. You'll then place the stainless steel sample in the block and lock it down. After this is complete, you need to attach the thermistor array. Instead of using 1, 2, and 3, you need to use 4, 5, and 6. That way, when you plot the results, they'll all be in a straight line. You'll then proceed to turn the control panel back on and let it allow steady state throughout the sample. After this is complete, you're going to check the temperatures just like you did in step 1 for each setting and each power setting. Alright, the final experiment is going to consist of a 1/2-inch brass sample. So like before, you're going to make sure the system is powered off, and you're going to remove the 1-inch stainless steel sample. Like before, you're going to apply thermal paste on the 1/2-inch sample, real thin, and lock it into place. And as you can see, there's no holes to read the temperatures on the last 2 samples. That's why you need to use a thermistor array for 4, 5, and 6 instead of 1, 2, and 3. Alright, now you come over here and turn the system back on. You wait for steady state, and you'll do like before. You read each temperature reading and power reading at each setting. And be sure to, as I mentioned before, the thermal paste, compound paste is very corrosive, so you need to make sure you wash your hands after use.
And
Finally, after you've completed all of the experiments, you're going to turn off the machine for the last time. You'll come over and you'll also turn off the water source that's feeding through the water flow rate. You're going to come over here and you're going to remove the final block that you tested. Get that out of there. And then now that you've done and you've taken it apart, you're going to go through and take a picture of each of the pieces of equipment, take pictures of the serial numbers and the manufacturers so you can get any uncertainty information from the suppliers. Just in case you can't find any uncertainty information, you'll come around and take pictures of all the measurement devices and whatever incremental measurements they use so you can calculate your own uncertainty. After you've done that, you're going to plot all the results that you've taken of the experiment and the data, and what you want to see is you want to plot it in Excel, add a trend line, and you want to have it show the R-squared value. The R-squared value is supposed to be greater than 0.97. If it's not greater than 0.97, you'll have to repeat that run for that experiment. And that's it.